Here is one of the most famous, complex, intelligent, and best operating systems in the world, the macOS. It has billions of users in the world. But have you ever wondered how such a complex and amazing system is created? Don't worry, this is what we're going to find out in this video. Every major release of macOS begins as a strategic brief. Product goals, user scenarios, and platform constraints are written down before a single subsystem is changed. Teams of product managers, designers, and engineers translate those goals into feature specifications, API contracts, and acceptance criteria that will guide months of engineering work. Designers create interaction and visual prototypes, while engineers decompose features into system services, frameworks, and kernel requirements. Decisions about backward compatibility, power and thermal budgets, and privacy shape which APIs are exposed and how they behave in edge cases. At the foundation of macOS sits Darwin and the XNU kernel, a hybrid kernel that blends mock microkernel concepts with BSD services to provide process, memory, and I/O management. This layered architecture gives Apple the flexibility to evolve userland services while maintaining a stable kernel interface for drivers and low-level subsystems. Apple publishes large portions of XNU and Darwin as open source. Engineers reference those repositories when implementing kernel changes, adapting scheduler behavior, or adding platform support for new Apple Silicon or Intel hardware variants. Device support and hardware integration are handled through IO-Kit and, increasingly, Driver-Kit. Frameworks that let driver code run with clear boundaries and modern APIs. Moving drivers into user space with Driver-Kit improves system stability and security while preserving performance for common device classes. Feature implementation proceeds in language-level modules. Swift and Objective-C components for frameworks like AppKit and Swift UI. C/C++ for low-level libraries, and careful API design to ensure third-party apps can adopt new capabilities without breaking. Unit tests, integration tests, and UI tests are written alongside code to validate behavior continuously. Build and integration use macOS build farms and Cloud CI. Xcode Cloud and third-party macOS runners automate builds, run parallel tests, and produce reproducible installer artifacts. These pipelines enforce code signing, run static analysis, and collect build metrics to catch regressions early. Security is enforced at multiple stages. Binaries are cryptographically signed with Apple-issued certificates and submitted for notarization, so Gatekeeper can verify integrity and scan for malware before installation. Apple's notarization and code signing processes are mandatory for smooth distribution outside the App Store. Quality assurance combines automated telemetry, crash analytics, and human testing. Apple runs staged developer and public beta programs to gather crash reports, performance telemetry, and user feedback. This iterative feedback loop drives weekly or bi-weekly seed builds as the release approaches. Packaging engineers create installer images and update payloads optimized for Delta delivery. Apple's software update infrastructure supports Delta and combo update strategies, so devices can receive smaller, staged updates that reduce bandwidth and risk during rollout. Before public release, Apple performs final validation, compatibility sweeps across hardware models, thermal and power regression tests, and staged rollouts that monitor telemetry for anomalies. Post-release, the cycle continues with security patches, minor updates, and developer guidance to maintain compatibility across the ecosystem. macOS is therefore not a single artifact, but a living system. an engineered combination of open foundations, proprietary frameworks, rigorous security controls, automated CI, and a global beta and distribution pipeline that together turn design intent into the desktop experience millions use every day. And this is how macOS is created. Share your thoughts about the creation of this amazing operating system in the comments, and don't forget to support us with your like and by subscribing into the channel. Stay tuned till next video.